In this video, we are going to learn about how to create a schematic symbol and PCB footprint for a full wave bridge rectifier. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is understanding the datasheet of 2W10 full wave bridge rectifier. Second step is to creating a schematic symbol using IEEE standards and user interface as a priority. Third step is to creating a PCB footprint using IPC standards and Cartesian geometry. Last but not the least, fourth step is to create and combine the component library of schematic symbol and PCB footprint so that you can use this component in your future project. So let's get started. Downloading the right datasheet from the right manufacturer is very essential. So I have downloaded the silicon full wave bridge rectifier from multicomp, which is having a part number of 2W10, which indicates a 1000 volt of peak forward voltage as well as 2 ampere of peak forward current. This particular bridge rectifier is considered as an integrated circuit. Why? Because it looks like this particular IC, which is having a 4 legs in a circular format. Now we are going to create a schematic symbol and PCB footprint for this one. The important thing is when you scroll a little bit down, you can see all the electrical details or the design documents required for using this particular rectifier in your project. But what we are interested is in this particular information, which is dimensions. This dimension is suitable for PCB footprint. What about the rectifier symbolical representation, which we already know? As a basics of electronics, we learned how to design a bridge rectifier or especially a full wave bridge rectifier using a diodes. We are going to use that symbolical representation in schematic symbol design and then using these dimensions in PCB layout design. Having said that, now I am on EasyEDA to start creating a schematic symbol of full wave bridge rectifier. I believe I need not to explain every step in this process. Why? Because in our previous videos, I have given a detailed explanation for each and every step that we carry forward in schematic symbol design. So let's get started. That's all. This is how you need to design a schematic symbol for 2W10 full wave bridge rectifier. I hope you understood the entire steps and you have created by your own self. Now it is time to understand how to create a PCB footprint and understand the Cartesian geometry based on the datasheet information. I'm in front of a datasheet and you can see that I have a bridge rectifier's detailed information. All these dimensions are in millimeter. Now the important part is the entire data is given with respect to the tilting angle. Now we need to make sure that we convert that information into something that we understand very easily. I would like to convert this entire circle as a symmetric with respect to the center as an origin. So what I will do, I'll consider this point as an origin somewhere here. And using that point, what I will do, I will divide this entire area into two sections like this. So if I divide it like this, you can see that the distance from this point to this point is going to be the same as 5.6 mm. The brocade one is in millimeters, the open side is in inches. So now we are interested in millimeters, so I'm going to consider 5.6 mm. The minimum is 4.6, maximum is 5.6. I'm going to consider maximum one so that it is easy for us to place the IC and solder it. I'm going to use this kind of a placement where I'm going to place one pad here, one pad here, and one pad here, and one pad here. Every pad on every quadrant. And the distance between these two pads and all these pads is always 5.6 mm. I'm going to divide this 5.6 by 2 and that value will be 2.8 mm. So using this information, I can place all these pads on every Cartesian point. This is how I'm going to design a PCB footprint using this datasheet information. I am back to EasyEDA and here I'll go to the file and create a new footprint. Here, as we discussed previously, I'm going to take pads and place them on all four quadrants just like this. The very important part here is to maintain the numbering. I understood that pin number 1 is a negative pin of the entire bridge rectifier and pin number 3 is a positive pin. So make sure that you maintain the pin diagram or pin number as you want on the bridge rectifier. However, it is a swappable part. You can place it however you want it because all the dimensions are equal and symmetric in nature. But it is always better to maintain a specific part, a specific pin and specific numbering for all the parts that you are designing. That is a professional way of designing a footprint library. So for that, what I'm going to do is I'll indicate the plus pin, which is pin number 3. Here it is, the plus pin, which is indicated by a rectangular pad. That indicates this is the positive pin of the entire bridge rectifier. And you can create this entire library however you want. You can rotate the pin number 3 from this point to this point or this point to this point. As I said, it is a circular one because of which you can rotate it however you want it. I have completed the creating a PCB footprint of 2W10 bridge rectifier. According to the datasheet, we identified the numbers and we inserted them using a Cartesian geometry. While saving this particular footprint, we have an option to give a title as a 2W10 or maybe a bridge rectifier. Instead of giving a 2W10, I prefer to give a name. Why? Because it doesn't have a specific package to be indicated. But bridge rectifier is a generic one which you can use for any other component which is having the same package. Which means a full wave bridge rectifier only, not 2W10, maybe another part number. If you give only 2W10, it means it is only dedicated for that particular part, which is not true. That's why we are giving a bridge rectifier as a name. And also in the description section, I have given it as 2WXX. You can give a 3x also. Why? Because this particular IC has a multiple ordering part number. You can see in the data sheet, if I scroll a little bit upside, you can see here 2W005 is also available and 2W100806 is also available. That's why based on that, you can give a 2WXX or XXX. And then we are going to save this entire part and we are done with creating a PCB footprint for 2W10. Now it is time to combine the schematic symbol and PCB footprint and to create a component library for full wave bridge rectifier that we are designing. For that, I have to go to the schematic symbol that I have designed and click on the footprint option and search for bridge rectifier. Click on the options that are visible in our account so that you can assign the right footprint that you have designed recently, and just make sure that all the pin numbers are matching properly. Why? Because you can see the plus pin, which is a number 3 pin, is attached to the positive pin of the entire footprint. Also, AC is attached to the AC section, and also DC and negative pin is attached to the negative pin of the schematic symbol. This is very essential. Why? Because it doesn't have any specific numbering in the data sheet, neither it has any specific icon indication. It is a symmetric one, so make sure that these numbers are matching. Thereafter, I'll click on the update footprint and then I'll close the entire wizard. Alright, you are done with designing a component library for a full wave bridge rectifier 2W10. Super duper! I believe you have understood and created your own bridge rectifier, schematic symbol and PCB footprint in EasyEDA by this video tutorial. If you have any questions or any feedback for our videos, please feel free to comment down below in this video. Thank you so much for watching this video. See you again in the next video. Until then, tune yourself to make a difference.